Hi, this is section 6.6, the inverse trigonometric functions. So they're going to define three functions: the inverse sine, inverse cosine, and inverse tangent. What you would need to know is the domain of these. So sine inverse is only going to be defined from negative pi over 2 to positive pi over 2. So right there, negative pi over 2, positive pi over 2, that's where sine inverse is defined. All right, as far as cosine is concerned, let's draw the domain of that. Cosine inverse is going to be defined from 0 to pi, as you can see from that domain there. And lastly, tangent inverse is going to be similar to sine inverse, which is going to be in the right semicircle. So it's going to be defined from negative pi over 2 to positive pi over 2, but not including those values because it's undefined at those values. All right, so let's look at this first example. So it says find the exact value of the expression whenever it is defined. So we're looking to see which angle, whenever you see inverses, they're referring to the angle. So which angle has a sine value of radical 2 over 2? And recall that you're only supposed to look in these two quadrants, 1 and 4. So in these two quadrants, we know sine is positive, so it's going to be in the first quadrant. And if you look at your unit circle, that would be right here, which is pi over 4. So the answer to this is pi over 4. So inverses are asking for angles. And you can either give it in degree form or radian form unless it specifies. If it tells you explicitly what it wants, then you should give them that, what they're asking for. But if they don't ask, then you can give whatever you prefer. All right, for this one, this is sort of a trick question because it appears that that's an angle, but that's not really an angle. We're looking for the angle that has a cosine value of pi over 2. However, what is pi over 2? Well, pi over 2 is approximately 1.57. And we know that cosine goes from 1 to negative 1, 1 to negative 1, 1 to negative 1. It oscillates back and forth. We know that the amplitude goes from 1 to negative 1. So, in other words, cosine can never reach that value because the highest value it can reach is 1 and the lowest is negative 1. So there is no such angle that has a cosine value of 1.57. So this is no solution. Okay, this one. So for tangent inverse, we're looking in quadrant 1 or 4, but because it's a negative, that means we're going to be looking in quadrant 4 here. All right, so let's look at quadrant 4. We're looking for the angle who has a tangent value of negative radical 3. So it's not going to be this one because that would be negative 1 if you divide y over x. So it's got to be either this divided by this or this divided by this. And it's going to be this one because when you divide y by x, y divided by x, you get the 2's to cancel and you just end up with negative radical 3. So it's going to be 5/3 pi. However, we don't call it 5/3 pi because that would mean that you'd have to go all the way around, and you're not allowed to go all the way around. You're only allowed to go this way or this way. So we're going in the negative direction. So it's going to be negative, not positive pi over 3, but negative pi over 3. So the answer is negative pi over 3. So you have to be careful not to use 5/3 pi because 5/3 pi is within the domain. Okay, for this kind of a problem, you're going to work from the inside out. So let's just ignore the outside function for now. Arc sine is the same thing as sine to the negative 1. It's just a different notation. So let's use this notation, or it doesn't matter. Either one is fine. So in this case, remember that inverse refers to an angle. So I'm going to call this angle alpha. So I'm going to draw a triangle in quadrant. Well, we know that inverse sine is defined in quadrant 1 or quadrant 4. Since this is negative, it has to be in quadrant 4. And we know that this is opposite hypotenuse, so that would be opposite hypotenuse. Remember, I called my angle alpha. You can call it any value you'd like. If you do the Pythagorean theorem, 100 minus 9 is 91. So this would be the square root of 91. And now, once you have the three sides labeled, now you can find out what the sine of alpha is. The sine of alpha is going to be opposite over hypotenuse. So opposite over hypotenuse is our final answer. Turns out we really didn't need this, but if this would have said, for example, tangent, then you would have needed this because it would have been opposite over adjacent. All right, let's look at this one. Same thing, let's work from the inside out, so ignore the outside function. This time we're looking for the cosine of 5/6 pi. Notice there's no inverse, so this is just a unit circle problem. Locate 5/6 and find the tangent value. 5/6 pi is here. The tangent is negative radical 3 over 2. So negative radical 3 over 2. This becomes, now we can uncover the outside function. The cosine inverse of negative radical 3 over 2 is what we're looking for. And now we're looking for the angle whose cosine value is negative radical 3 over 2. So we go back to the unit circle, and that would be in quadrant 2, and it's going to be 5/6 pi. And that is a legitimate value because it's in the domain of cosine inverse. So 5/6 pi it is. All right, so now this one, same thing. Let's work from the inside out. Let's cover that up. Let's figure out what tangent of 7/4 pi is. 7/4 pi is here. The tangent is y divided by x, which is negative 1. So this becomes arc tan of negative 1. So we're looking for the angle whose tangent value is negative 1. Since it's negative, it has to be in quadrant 4. So this would be the coordinate that has a tangent value of negative 1. So the answer is not 7/4 pi because that's not in the domain. So instead of going to positive pi over 4, you would go to negative pi over 4. So you would call that negative pi over 4 instead of 7/4 pi. Because negative pi over 4 is in the domain of the inverse tangent, whereas 7/4 pi is not in the domain. All right, this one is a double angle. This is going to be, we can call this one alpha, we'll call this one beta. So let's draw these two triangles out. One for alpha and the other for beta. So let's start with alpha. Alpha is negative and it's tangent, so it's got to be in quadrant 4. That's opposite over adjacent because it's tangent. And beta is going to be in quadrant 1 because it's positive. And that's our beta. And that's opposite over hypotenuse because it's sine. Sine is opposite hypotenuse, opposite hypotenuse. This is a 3, 4, 5. And this is also a 3, 4, 5. Right, once you have that, we are calling this alpha, we're calling this beta. So we have to use the difference formula. If you recall, the difference formula is cosine plus sine. You can refer to your formula sheet if you need to. All right, so now we can use our triangles to figure out these ratios. So cosine alpha is 4/5. Cosine beta is 3/5. Sine alpha is opposite hypotenuse. And sine beta is opposite hypotenuse. right, we got it all. And so now we have an LCD of 25, and we have 12. Take away 12 is 0. So all of that work just to get 0. Okay, this next problem says write the expression as an algebraic expression. So once again, inverse tangent is either in quadrant 1 or 4, but because x is positive, that means we're in quadrant 1. So let's draw a picture of this triangle. We're in quadrant 1. I'm going to call the angle alpha, and that is opposite over adjacent. Opposite over adjacent. And if you do the Pythagorean theorem, we'll call that c for now. C squared is equal to a squared plus b squared. So c squared is 4 plus x squared, which means that c is the square root of 4 plus x squared. So now we have the hypotenuse is the square root of 4 plus x squared. And finally, we can find out what the cosecant of alpha is. Cosecant is hypotenuse over opposite. So our final answer is going to be hypotenuse over opposite. All right, the last problem of the section. Use inverse trig functions to find the solutions. So notice that this is a quadratic type of an equation that can be factored. And if you factor that, it's going to be cosine of x times cosine of x is going to give you cosine squared. And then in order to get 1, you need a plus 1 and a minus 1. And that is not going to work, actually. So it turns out that this is not factorable. So because it's not factorable, we have to resort to the quadratic formula. All right, so let's do that. So let's call this y is equal to cosine of x. I'm just going to do a substitution. So we let y equal to cosine of x. Then we have y squared plus 2y minus 1 equals 0. Quadratic formula is going to be y equals negative b plus minus the square root of b squared minus 4ac all over 2a. So that's going to be negative 2 plus minus the square root of 8 over 2. All right, and now we're going to have, this is going to simplify to negative 2 plus or minus 2 radical 2. And now you can cancel these 2's out. You're going to get negative 1 plus or minus radical 2. Okay, so we have two solutions, negative 1 plus radical 2 and negative 1 minus radical 2. So we go back to our y substitution. So y is going to equal to, cosine is going to equal to negative 1 plus radical 2, and cosine is also going to equal to negative 1 minus radical 2. Okay, I would recommend that we get this decimal representation just to see if there's a solution. So what's negative 1 plus the square root of radical 2? Negative 1 plus the square root of radical 2 is 0.41, which means this one does have a solution. All right, so in order to find it, you would just take the inverse. So x is going to equal to inverse cosine of negative 1 plus radical 2. That's the answer. All right, we could use our calculators to find out what the degree measure of that is, but I'm going to leave it in exact form. Let's see if this one has a solution. If you do negative 1 minus radical 2, you're going to get negative 2.4. Remember we said that cosine can't be greater than 1 or less than negative 1, so this one is not going to have a solution. So the only solution is this one, and that concludes the section.